So when we will do revision, so the chapters that is reflection of light and diffraction of light will be covered there for you. Okay, so after I think half an hour, we will start the electricity. So a topic that earlier I have covered, atmospheric refraction, and after that twinkling of stars. After that this. Okay, these topics I think I have covered, and now we will discuss the scattering of light. So what is the scattering of light? Scattering of light means suppose here is a bulb and here is also a bulb. So these bulbs are giving up light. So these lights are getting spread in all the direction. This is known as the spreading of the light. Uh, you have already seen these things. You can see here the sky. The sky is blue. We know the sky seems to be blue to us. And the sky is blue. So why it is blue? There will be a reason. And the reason is the scattering of the blue light. Because sunlight contains 7 colors. Sunlight contains 7 colors. So most part of the sunlight is red color or blue color. Mostly in sunlight there is a large amount of red or blue colors. So the sky is blue due to the scattering of blue light. I will explain this later. And sunset and sunrise are red. This is due to the scattering of just red light. Okay. Okay. So scattering of light means to spread the light in all the direction. Can just write one line. Spreading of light in all directions. After this, we have one topic. Actually, what happened in 1859? There was a scientist, Tyndall. Tyndall, you can say Tyndall. Uh, he discovered that when the white light is passed through a liquid, okay, and that liquid have some particles, suspended particles. So the path of the light is visible. Okay, the path of the light is visible, and there is a scattering of blue light there. See how this happened. Okay, so what he did, uh, this is just a normal solution, normal water. Okay, and here is the water, and this water have some extra added particles. Okay, so when the light is passing from this, okay, this or this, so here you can see uh, there is a scattering of light taking place. There is a scattering of light taking place. You can see light is striking on these particles, and light is scattering in the directions, all the directions. So that is why the particles are visible here. Particles are visible, but here the particles are not visible. Here the particles are not visible. Okay, in this case, because here the size of the particle is comparable to the wavelength of the light. Here the size of the particle is smaller than the wavelength of the light. So now what is Tyndall effect? We will so Tyndall effect is basically when the light passes from a suspended solution, this is a suspended solution. Suspended solution means in which the extra particles are added, and due to the scattering of the light, the path of the light becomes visible. Okay, and scattering of light takes place. You can see this picture. In this picture, this is the scattering of sunlight. I don't know whether have you seen this or not. This phenomena takes place in jungle. The scattering of sunlight passing through the canopy of forest. When the light passes uh, through the forest, so what happens? There is a fog or mist. So in fog or mist, there are small water droplets or moisture, and from that moisture, the light just falls on those particles, and due to that, the scattering of the light takes place, and the path of that moisture, or you can say the path of the light becomes visible due to the scattering of light. You can take one more example. If there is a room, in that room there is a dust particles. In that room, suppose there are dust particles, and sunlight is coming through the window, then also you can see the same effect. What will happen? The sunlight will just strike on those particles, dust particle, and scattered around the room. So you can see those small dust particles. You can observe that also. So what is Tyndall effect? Tyndall effect is the scattering of light when the light passes through some, when the light strikes on some particles. Tyndall effect. The scattering of light scattering of light by particles in its path okay is called Tyndall effect. Simple. Called for example, examples of Tyndall effects I have told you. When in a dusty room, when the sunlight is there, so when the sunlight falls on the particles, due to those particles, the scattering of sunlight takes place. Okay, this is known as the Tyndall effect. For example, sunlight becomes visible as it passes through dust particles in the room. There is one more example. This example you can take. This is also the Tyndall effect. What is happening here? Sunlight is coming. There is fog or mist, you can say, and fog contains the small water droplets, and light is just striking on those droplets and is scattering. So that is why this is looking like this. This is also the Tyndall effect. Okay. So I am not writing this. So there is one note point I have told you earlier also. In white light, mostly there are red and blue colors. In white light, red and blue are very predominant okay, and we also know that the wavelength of red light is large wavelength, and compared to the red light, the wavelength of blue light is small. Almost the wavelength of the red light is twice of the blue light. Remember one point, larger will be the wavelength of the light, lesser will be the scattering of the light. Larger will be the wavelength of the light, lesser will be the scattering of the light. So red light is scattered very less as compared to the blue light. Okay, so you can write here blue light having short wavelength, so blue light will scatter more. Okay, red light have large wavelength, so it will scatter less. You can say that blue light scattering is 10 times more than the red light scattering. Blue light scattering, just for example, additional information, blue light scattering is 10 times more than that of red light scattering. So what is Tyndall effect? If someone is saying what is Tyndall effect, so you will say scattering of light by a particle in its path is called Tyndall effect. If they are asking, give the example of Tyndall effect, so you will write sunlight becomes visible at as it passes through the dust particle in the room. Okay, so you can see this is the just practically I want to explain what is the Tyndall effect. What is the Tyndall effect? Okay, you can here also you can see this is a solution when the light is just the light is falling from the solution, and this solution contains some particles, and these particles are just scattering the lights. That is why these particles are visible here. After that, there is one last topic we have: why the sky is blue. Why the sky is blue? Why the sky is blue? Because you can just imagine there is a sun, and sun gives the light, white light. Sun basically gives the white light. So in the sunlight there are 7 colors. There are 7 colors in the sunlight. So what happens? I have told you that in sunlight, basically the red light and the blue light are predominant. Told you, na? So when the sunlight is coming from the sun and enters in our atmosphere, so what happens in our atmosphere and during the path of the sunlight travels. So there are some particles are there. Okay, there can be some particles in the atmosphere. So what happens when the light strikes on those particles? Due to those particles, when the light strike on those particles, so those particles scattered light in all the direction. But what happens? Red light uh, scattered least, and blue light scattered more. So that is why there is the more scattering of blue light as compared to that of red light. That is why the sky mostly blue. Sky is blue. Okay. So you can just, this is explained in this figure. What is happening here? This is the sun, and sunlight from this sunlight is going in this direction. In all the directions, sunlight will go. So sunlight is a mixture of 7 colored, we know. So sunlight is going in this direction, in this direction, and in this direction. Uh, Sunlight is entering to the atmosphere. Okay, and in the atmosphere, what are there are some particles. Okay, so due to those particles, you can see there is a scattering of blue light. There will be the scattering of red light also, but that is very small, so that we have neglected. So here the blue light, you can see a little of blue light is scattered. Not all the blue light is scattered. Okay, little of blue light is scattered due to the particles. Here also there is a scattering of blue light. Why the scattering taking place? Because there are the particles in the path of the sunlight. Okay, so that is why the sky looks blue. So you can see blue sky from the scattered light. Scattering of light, or scattering of a little blue light present in the white light by air molecules. I have told you now, there will be the particles, like you can say air molecules are there in the atmosphere, make the sky appears blue. So what happens in our atmosphere? There are air molecules or particles, and sunlight falls on those particles, scattered, and mostly the blue light will scattered because of the short wavelength. That is why the sky looks the blue. Okay, you can note it down, and I think this chapter is finished now. So okay, so you can just note down from here, and now we will start electricity. Hamna and Eman, are you getting it? Okay, Aman. So we are starting now the electricity. Okay.
Okay.
Very interesting chapter, electricity. And now we know that how much the electricity is important for our life. Without the electricity, even we cannot interact through these classes also. Hamna, when completed, you can write down in the chat box. Okay, write down fast. Completed, Hamna? Okay. So remember this point. Okay. Blue light will scatter more. Red light will scatter less due to large wavelength. Now this diagram is very important. In examination also, you can draw this diagram. Just draw this diagram and everything will be clear. Why the sky is blue? Answer is this diagram. Aman, do you have any doubt regarding this?
No, clear.
Okay. The sky is blue due to the scattering of blue light as it has short wavelength, so that the scattering of blue light takes place more and the sky appears blue. And why the scattering is taking place? Because of in our atmosphere, when the sunlight enters in our atmosphere, there are the particles, there are the air molecules, and there are the particles in the atmosphere. So when the light strike from those particles, the light will spread in all the direction, and mostly the blue light. That is why sky appears blue. So try to imagine in your mind what is happening. There is a sun and light is coming from the sun. So and there is atmosphere, and in atmosphere there are some particles, there are some air molecules, and light is coming. Light will strike those particles, and we know that whenever the light strikes some particles, there is a scattering of light and related with the wavelength of the different light in sunlight. Okay. So we have the blue light and red light predominantly in the sunlight. So blue light will scatter more, and red light is scattered but very less amount. So that is why the sky is not red but looks blue. Okay, Hamna, done. So this thing na is representing scattering of light in the directions. Hamna, done? Should I move now to the next chapter? Now completed.
Yes, sir.
And Hamna, completed. Okay. Okay, so now we will move to the next chapter, electricity. What is the chapter? Electricity. Now see this city. If in this city there is no electricity, then you can imagine what will be the condition. This is New York City, for example. And if there is no electricity in the city, then you can imagine what will be the condition. There will be the very pathetic condition, I guess. So now, how the development of the electricity started. First, we will discuss little bit that, and then we will move. So first of all, I want to tell you, in earlier days, someone has just discovered the electricity somehow. Uh, what happened? Means, for example, I'm just giving a simple example. If you have a comb and take that comb, hair comb, and take some pieces of the paper, small pieces of paper, take small pieces of paper and take one comb, and just suppose in my hand there are pieces of paper, and this is the comb. So I will just uh, take this comb near to the pieces of paper, so I will see no, nothing is happening, means no effect on the pieces of paper. After that, what I'm doing, suppose I have just my dry hair and I have just little bit of like this, okay, rubbing the comb with my hair like this, and after that, again in my hand there are tiny or small pieces of paper. So what will happen there? You will see there will be the attraction. The comb will attract those pieces of um, paper. Now, how this is happening? Why is there any magic? Why this is happening? There should be an explanation. So for this, what happens earlier when uh, there was a comb, and earlier I have just take the comb near to these pieces, there will be no effect. There was no effect. Why? Because that time the comb has electrically neutral, means comb do not have any charge. We will discuss charge. And when I have rubbed the comb with my hair, so due to the friction, you will get to know the comb got electrically charged, and due to the comb got some charge, and due to that charge there is an electric force applied by the comb on these particles, on these pieces of paper, and those pieces of paper got attracted. So basically what is happening now? Charge is the thing here. There is a thing, charge, that lead to the electricity or that lead to the current. In this chapter we will study these things in detail. Same effect can be seen when a glass rod is rubbed with a silk cloth. Take a glass rod, rubbed it with a silk cloth, then you will see again there will be some charge got by the glass rod. Okay, so by rubbing the glass rod and by rubbing the comb or ebonite rod, there will be some charge. You can just relate it. Now electric charge. So there are two types of electric. Experimentally, someone has done the experiment, I do not know the name. Electric charge, basically electric charge. So the story begins with the electric charge. So electric charge, if I will define it is very difficult to define what is the charge. There cannot be the absolute definition of the electric, but then also I am defining electric charge is just the fundamental property of the matter, or you can say intrinsic property of the matter. So I'm not going in that. So basically I want to tell you there is an electric charge, and electric charge is of two types. I think you all know there are two types of electric charge, positive, and I am not saying this is of two charge. This is founded by the experiment. Electric charge is of two types: positive charge and negative charge. Positive charge and the negative charge. So electric charge is of two types: positive charge and negative charge. So earlier it was assumed that, means by convention you can say, uh, the charge acquired by the glass rod rubbing with silk is considered as positive charge. Earlier it was just said. And the charge acquired by, there is a rod of ebonite rod rubbed with the woolen, is a negative charge. Okay. So we will write that also for your knowledge. So you can write here by convention. By convention, the charge on the glass rod due to rubbing it with silk cloth, with silk cloth, and by convention means earlier they have just defined the charge like this: the charge on the ebonite rod rubbed with woolen cloth is a positive charge. Okay, positive charge. And charge, I will just symbolize the electric charge as q, small q. Okay, after this there are some properties of charge. There are some properties of charge. If I say I have two charges, one is positive charge and another is also positive charge. If I have two charges, same charges I have, one is positive, another is positive. So both the charges will repel each other. Positive charges or same charges, or if I can take also negative charge also. Two negative charge are there. They will repel each other. They will repel each other. And why they are getting repelled and why they are getting attracted, if you will have physics in your 12th, then you will get it by the Coulombs law. Okay, there is a Coulombs law there for the electrical charges. So then so basically here you have to understand uh, similar charges attract, repel each other, and when you have two dissimilar charges, like one is positive, another is negative, so both these charges will attract each other. Both these charges will attract. So here is a repulsion between charges, and here is the attraction. So this is a rule of the nature, you can say. Positive charge will repel each other and negative charge will attract each other. So you can write opposite or unlike charges attract each other. For example, if you have a positive charge here, if you have a positive charge, they will attract. If you have a negative charge here, you have also negative charge, they will also attract, because they are sorry, what if you have a here positive charge and here is a negative charge, okay, so these charges will attract. Why? Because these are opposite or unlike charges. Another, if you have a like charges, like or similar charges, okay, like charges repel each other, repel each other. For example, if you have a negative charge and here is also a negative charge, so these charges will repel. For example, if you have a positive charge here, if you have a positive, two positive charge like this, then again these charges will repel each other with a force, and that force is given by Coulomb's law. In 12th class you will study that. There is a unit of length, that is meter. Unit of length is meter and unit of force is Newton. Like that, unit of charge is Coulomb. SI unit of charge is Coulomb. So unit of charge So we will talk about the SI unit. SI unit means S dot I, means international system of units. So SI unit of charge is Coulomb. Basically, this Coulomb was scientist. He had given the Coulomb's law. So SI unit of charge is Coulomb. 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 Okay. Now, after this, we will define 1 Coulomb. 1 Coulomb. What is 1 Coulomb? We will define. Basically, 1 Coulomb can be defined with the help of the Coulomb's law, but Coulomb's law is not in your syllabus, so we can define like 1 coulomb is the quantity of that charge, when an another charge placed at a distance of 1 meter from it, there is a force of interaction of 9 into 10 to the power 9 Newton. Okay. So we can just write what is 1 coulomb. 1 coulomb is that amount of charge, charge or you can write that quantity of charge. That quantity of charge which exerts a force of 9 into 10 to the power 9 Newton. The unit of force is Newton, no? On an equal charge, placed at a distance of 1 meter from it. I can prove this also, okay, but the proof is not the part of your syllabus, so you should learn this, okay, fine. So what they are saying, if you have a charge of 1 coulomb, 1 coulomb charge, you have charge q is I have represented the electric charge as q is equal to 1 coulomb charge if you have. And what they are saying, if you have placed another charge of 1 coulomb, if you have placed another charge of 1 coulomb at a distance of 1 meter, you have placed, here also there is a charge of 1 coulomb, then there is a force of interaction, or you can say this charge q will apply a force on this charge. The force can be in the attraction, or the force can be repulsion also, depending upon the condition. So this is the force exert by 1 coulomb charge on this. So this is the 1 coulomb. Okay, I want to calculate. Before that, we know that matter. Can anyone explain what is matter? MATTER, matter. Aman? Don't know what is matter? Okay. Matter, you can just define matter like anything which have space and have mass is matter. So I am a matter, you are a matter, this laptop is a matter, all things are matter here we have. So we know that matter is there, and this matter is made up of what? Everything is made up of atoms. So matter is made up of atoms. And atom, do you know what is atom? In atom there are electrons and protons. Nucleus also is there. I am telling you what happens in an atom. Okay, in an atom, at the center there is nucleus, positively charged, and electrons are there, and these electrons revolves around the nucleus. I have shown 1 electron, there are any number of electrons are there. Okay, this is the nucleus. and this is the electron. And in nucleus, there are protons and neutrons. Okay, in nucleus there are protons and neutrons. So in atom, what we can say, have the protons and neutrons, electrons and protons. Electrons are there in atom, proton are there, protons. But remember, protons are inside the nucleus, and protons are positively charged and electrons are negatively charged. This have the negative charge. Electrons have negative charge. Negative charge, how much negative charge the electron have? Minus of 1.6 into 10 to the power minus 19 Coulomb. And how much charge the proton have? Proton have the positive charge, and it have a 1.6 into 10 to the power minus 19 Coulomb. Both have same charge, but electron have negative and proton have positive charge. Okay. So this electron is negative here. So there will be a force of attraction or will be between the nucleus and the electron. This will be used when we will discuss the conductors and insulators. Okay, Aman, are you getting it? Better tell me.
Yes.
If you have any doubt, then please you can ask me. Hamna, what about you? If you don't want to speak, then you can write in the chat box. Hamna, are you getting? Okay, Aman, please write down. Okay, so there is no requirement of this picture. Uh, just write the electric charge from here. You can write. If both of you, if you want to ask anything related to this, then you can free to ask. Okay. So charge I will represent with a small q, electric charge. Aman, when you have completed this, you can ask me to scroll down. Okay. So in this chapter, a lot of things about the electricity we will study. This is just the introduction part. From the charge, it is started, and it will be end to the power. So after this, we will discuss the conductors and insulator. After that, we will discuss what is the potential difference, what is the resistance. Resistance is in series, resistance is in parallel, energy, what is the relation between the energy, and all these things we will study in this chapter, and we will solve equally the numericals also. Written, Hamna? Hamna, are you there? Beta, please respond, na. Aman, completed this?
Yes, sir. Done.
Is my voice not okay?
No, it's clear.
Okay, write down. So 1 Coulomb, remember what is 1 Coulomb? So the proof of this can be given by using the Coulombs law. And Coulombs law is not the part of your syllabus. If you have a physics in your 12th class, then in the very first chapter you will study, and the first topic you will study after charge is Coulombs law. So there you can just prove it, how this 9 into 10 to the power 9 is coming. Completed. Scroll down.
Yes, sir. Yes, sir. Done.
Hamna, you also completed?